Hello everyone. So this video is going to take off from where the previous video ended. So we have this matrix A here, which now describes the flow of goods between the two industries, I1 and I2. And we're told that I1, the first industry, is now producing $500 worth of output, and I2 is producing $400 worth of output. Now, I want you to focus on the first row here. And what does this first row tell us? That the first industry is using 50 units of its own output in order to 50 units of its output in order in its own production. And it's now using, so it's using 50 units of its own output to produce its own product. And then it's using 200 units in producing the output of the second industry. So in total, the first industry is now producing $500 worth of output. And of that $500, $50 are being cycled back into its own production. So we have 50 being cycled back into its own production. And it's giving $200 worth of its output in order for producing I2, which is the output of the second industry, which means 200 is going to the second industry. And in total, I1 is producing $500 worth of output. So if 50 is cycled back into its own production and 200 goes to the other industry, that means we are left with another 250, right? So from 500, 50 goes away, and then another 200 goes away, which gives you $250 worth of output for final demand. And this could be maybe $250 worth of output is what is going out as sales that the households can then purchase. So that's that 250 now becomes the $250 worth of output from I1 now goes towards final demand. And can we think of a similar set of numbers for the second industry? Absolutely. Now the second industry produces $400 worth of output, and it uses about $80 worth of output to produce its own product, meaning this $80 goes from I2 to I2, and this 80 is now cycled back. So out of this $400 worth of output produced, 80 is now cycled back into producing I2. So this will be 50. And then $150 worth of output from the second industry goes into producing I1's output. So which means I2 is now sending $150 worth of output in order to produce I1's output. Now, if out of 400, if 80 is cycled within itself and 150 goes to the first industry, then what is remaining? So we have 400 minus 80 minus 50. So this will be 400 minus 230, which gives us about $170 worth of output for 400. So essentially what we've now done is we have constructed another matrix of final demand, and I'll show that to you in just a moment. The idea here is that when you describe a system in this manner, you can then use the technology matrix to actually, this technology matrix that we see, we can actually use that to answer 3 different types of questions. Now, if we are given the total output and the technology matrix, then we can then compute how much of output is then set aside for final demand. So how much of output is available for final demand given the total output that's being produced, of course, and given the technology matrix. And then a second question that we can ask is, given the technology matrix and a certain level of final demand, how much of total output would you need in order to satisfy this inter-industry flow as well as the final demand? So that's another question we can ask. And the third thing is, If the final demand changes by a certain amount, then what changes need to be made to the total output? And we'll try answering each of these three questions in detail using certain examples. But before that, we need to bring in a few more elements into our toolkit. Now, this is a technology matrix that we started off with, which tells me that for $1 worth of output from I1, we need, okay, wait, let me make this look a bit neater. Apologies for the confusion there. Now, if this is I1 and this is I2, to produce $1 worth of output from I1, we need 10 cents worth of input from I1 and 30 cents worth of input from I2. And similarly, to produce $1 worth of I2, we need 50 cents of I1 and 20 cents of I2. Now, let that be the technology matrix, and let the total output of I1 and I2 that are actually produced, let that be X1 and X2. Maybe you can think of X1 as $500 and X2 as $400. You can put it that way. And let the final demand for I1 and I2 be denoted by D1 and D2. And in this particular example that we saw here earlier, when X1 and X2 are 500 and 200, we computed D1 and D2 to be 250 and 170. All right, now let's generalize and put certain variables in their place. So we have X1 and X2, which is the total output that's actually produced, and D1 and D2 denote the final demand. Now, from its total output of X1, which is actually the output of industry 1, it is going to use 0.1 times X1, and that will be the input that it's using in its own production. So, so to produce $1 worth of output, if it needs 0.1, if it needs 10 cents worth of its own output, then to produce X1 dollars worth of output, it's going to need 0.1 into X1 dollars worth of its own input, right? Which is exactly what is denoted by this statement. And similarly, to produce, we saw earlier here that to produce $1 worth of output, it needs 0.3 cents of input from the second industry. So to produce X1 dollars of output, it's going to need okay. I think I just confused you for a second there. Let's deal only with the first row. We're talking about how much inputs are flowing out of A1. It's now going to need 0.1 times X1 units to produce itself. And then for every unit of I2 that is produced, I1 is giving 50 cents of its own input. Okay. So for every, so this is, okay, so if I2 is producing $1 worth of output, I1 gives 50 cents of its input. If I2 is now producing X2 dollars worth of input, worth of output, then the input that will correspondingly flow from I1 is now going to be 0.5 times X2. Okay, and all I'm doing is just looking at the first row and generalizing it. And if it helps you, if you think it will be easier to put some numbers here, please plug in X1 equals 500, X2 equals 400, and check it with the matrix that we just derived here, put up here, and then you will see how the numbers are actually coming to be. And then the total output from X1 is also going to satisfy final demand, right? Which was D1. And if you see in the earlier chart, this was actually 100. So 50 plus 200 plus 250 is equal to 500. So that's the exact thing that I'm saying, except that instead of numbers, I'm giving you variable names. So from its total output X1, and therefore the total quantity of I1 that's going to be used up is 0.1 times X1 in its own production, plus 0.5 times X2 to cater to I2's production, and then D1 units for final demand. So this will be the total quantity of I1's output that is actually used. Now, if we assume that the total output that this first industry is producing is just sufficient to satisfy these requirements, then we can say that the total amount of I1, the output of I1 that is produced is X1. So this amount that is actually produced is enough to satisfy all of these requirements, which is taking care of its own input, providing for the input of the second industry, and catering to the final demand. Now, this is the first equation that we'll be considering. And this is just for the first industry. When you have n industries, you're going to have n equations of this sort. So let's generate the equations for the second industry. Now, I'm just going to quickly put down the matrix here just for ease of reference. We have 0.1, 0.5, and then 0.3 and 0.2. So we have I1, this is output. Now, from its total output X2, industry 2 is now going to give 0.3 for every unit of I1 that's produced. So if 0.3 for 1 unit, then it's going to be 0.3 times X1 for X1 units of production in I1. And for its own input, industry 2 uses 20 cents worth of its input for $1 worth of output. So for X2 dollars worth of output, it's going to use 0.2 times X2 dollars of its own production as an input. And then there is also going to be final demand of D2. Therefore, the total quantity of I2 that is used will be 0.3 X1 plus 0.2 X2 plus D2. And if we assume again that the total output from I2 is actually just enough to meet all of these requirements, we have another expression. So we have the second equation. So now we have two equations and we want to start using matrices. So how does that happen? Well, I've just written down these two equations again. Now, can I put this into a matrix form, matrix notation of this form? X is equal to AX plus B. Yes, we can. X is just going to be this column vector, which denotes the total output that is produced. A now becomes technology matrix multiplied by the total output vector and add a final demand vector. So when you actually expand and multiply these matrices and write down the final expression, the first row will actually give you the first expression, and the second row will give us the second expression. Now, so this is a case of a 2 by 2 when there are only two industries. And when there are n industries, you can think of much more complex, larger matrix system. So where you have an n by 1 output vector and an n by n technology matrix and an n by 1 final demand vector. So we don't have to worry much about these n industries, but I just thought it's useful to see the n-dimensional notation there. For the purposes of our focus here, we are only going to focus on this particular expression here. And remember the three questions that I mentioned just a minute ago, depending on calculating output for final demand and calculating final demand given output and understanding what happens to the system when demand changes. All of these questions can now be answered once you put things into this particular matrix notation. So we'll answer those questions in a subsequent video, so I will see you there.